Bon, on continue toujours l'aventure de télétranslation et là sur la semaine de C. Ouais, on continue toujours. Le C. Donc, c'est parti.
This time like a little calculator of sorts. Let me propose that we implement a very baby calculator, or rather not even a calculator yet. Let's just compare some few values. So let me do this. Code of compare.c to create a brand new program called compare. And then in here, I'm going to do a bit of boilerplate. I'm going to go ahead and include cs50.h. I'm going to go ahead and include standard.io.h. And I'm going to go ahead and do int main void. More on that next week. And then inside the curly braces, let's use these new techniques. Let's give myself a variable called x and set it equal to the return value of getInt, that other function I promised exists. And let's prompt the user for a value for x with a sentence like, what's x, question mark. And then a space just to nudge the cursor over. Let's get another variable, y, set it equal to getInt again, and ask the user this time, what's y, essentially using the same function twice, but to get two different values. Now, let's go ahead and do something pretty mindless. If x is less than y, go ahead and print out with printf, x is less than y, \n to move the cursor, close quote, semicolon. So it's not that interesting of a program, but it's at least dynamic in that now I'm prompting the user for two numbers. So let's do this. Make compare, enter. Seems to have worked. And in fact, I can check that it worked by typing what command to list the files in my directory? ls for short. And now you'll see I've got hello.c, but no hello because I deleted that with rm a few minutes ago. I've got compare.c, which I just created. And then I've also got a program called compare. And the asterisk there is just a visual indicator that this is executable. It's a program you can run. It's not just a simple old file. Even though I didn't type ls previously with hello, it would have similarly had an asterisk next to it in this context. But you don't see that in the File Explorer. If I now do compare, well, let's do something silly like 1 for x, 2 for y. OK, x is less than y. Let's do it again. /compare. 2 for x, 1 for y. OK, and I see nothing. Well, why am I seeing nothing? Well, logically, I didn't have a condition for checking for greater than, let alone equal to. So let's enhance this a little bit. Let me go ahead and minimally say, all right, else if x is not less than y, let's go ahead and print out x is not less than y \n, close quote, semicolon. So I'm at least handling that situation too. Let me clear my terminal window, do make compare again, /compare. 1 and 2 works exactly the same. Now let me go ahead and do 2 and 1. There we have better output. Of course, it's not really complete yet, because if I do /compare again and do 1 and 1, it'd be nice to be a little more specific than x is not less than y. It's not wrong, but it's not very precise. So I can add in to the mix what we did earlier. And I can say, OK, well, else if x is greater than y, say x is greater than y. Else if x equals y, go ahead and print out x is equal to y \n, close quote. But here, too, someone observed that this is sort of stupidly inefficient. What line of code should I actually improve here to tighten this up? Yeah? Yeah, so line 17, I think I can just get rid of that unnecessary question, because logically that's going to be the case at this point. And now I can go ahead and recompile this with make compare, /compare again, enter, 1 and 1. And now we're back in business, catching all three of those situations, those scenarios there. Questions on any of these things here? Why have I deliberately not done this? Let me rewind just a moment, and let me hide my terminal window.
Et puis, ok. Puis j'écris toujours mal. Pourquoi il me donne deux réponses? On va prendre ça. Ça, c'était juste pour me rappeler un truc. Je pense parce que là, depuis on utilise un get int. Mais là, c'est juste avec ça. Mais d'ici, je veux pas utiliser le librairie. Qu'est-ce que je fais? Je me rappelle. Ça, je me vois dedans. Tu fais un print F. Puis maintenant, tu fais un scan F. Ça, depuis, je t'en réduis, mais c'est encore pas.
Just to keep the emphasis on the code here, why not do this and keep my code arguably simpler? Like, why not just ask 3 questions? Step 9, step 13, and step
J'avais oublié
17.
semi-colon ici.
Yeah, what don't you like?
Attends, get int. Ouais, machin truc. Ça.
Exactly. It's another example of bad design because now, no matter what,
Ok,
you were
ça,
asking
c'est
3
clair.
questions on lines 9, 13, and 17. Even if x ends up being less than y from the get-go, you're still wasting everyone's time by saying, wait, well, is x greater than y? You already might know that it's not. Is x equal to y? You already might know that it's not. And so these 3 conditionals, at the moment, are mutually exclusive, whereby you're checking all 3 of them no matter what, even though logically that shouldn't be necessary. So our first approach was actually quite better. And in fact, just to show you the density difference here, let me go back to this very first version here, whereby I was only checking that one condition, is x less than y? Well, if you're more of a visual learner, you can actually draw out what code looks like in flowchart form. So here is a drawing of a program that starts here and ideally stops down here, and each of these figures in the middle sort of represent logical components of the code. Here in the diamond here is my Boolean expression, which represents the start of the conditional. So if x is less than y, I have a decision to make, yes or no, true or false. Well, if it is less than y, true, well, let's go ahead and print out, quote unquote, x is less than y, and then stop. However, the first version of that program, recall, just said nothing if it were not the case that x were less than y. That's because false just led to the stop of the program. There's no keyword stop. There's just no code to handle that situation. But the second version of the code, when I actually added an else, looked fundamentally a little different. So now, second version of that code asked, is x less than y? And if true, behavior is exactly the same. But if it weren't true, it were instead false, that's when I got the message, x is not less than y. But in the third version of the code, where I added the if, else if, then the picture gets a little more complicated. And let me zoom in top to bottom. Here we have a longer flow chart, but the questions are really the same. When I start this program, I ask, is x less than y? If so, I print out, x is less than y. However, in that last version of the program, I was still foolishly asking the same question. Well, wait a minute, is x greater than y? Wait a minute, is x equal to y? And that's the version in which, again, I had all of that unnecessary code, which I just undeleted here, asking 3 questions at a time. Ideally, I don't want to make that mistake by doing it again and again and again. So if I instead revert that code to else if, and else if, then my flow chart looks a little bit different because notice the sort of shortcuts now. If x is less than y, true, we do this and we're done, super quick. If x is not less than y, fine, we do ask one more question. X is greater than y? Well, if so, boom, we make our way to the end of the program by just printing that. Only if it's the perverse case where x equals y, do we check this condition? No. This condition? No. This condition, and then, okay, now we can print out x is equal to y because it must be logically. Of course, it's been observed multiple times. This is a waste of everyone's time, so we can prune this chart more and just have 1 question, 2 questions, and that alone tightens up the program. So again, if you're more of a visual learner, most any block of code you can translate to this sort of pictorial form, but it really just captures the same logical flow that the indentation and the syntax in the code itself is meant to imply. All right, how about a final exercise with one other type here? Recall that this is our available types to us. Actually, 2 final examples here before we have a bit of a break. Here we have a list of types that we can use, and here we have a list of functions that we can use. Let's go ahead and make a program that's representative of something we do quite often nowadays, but using a different type. So let me go back into VS Code. Let me close compare.c. Let me reopen my terminal window and clear it, just so we have a new prompt. And let's go ahead and create a program called agree.c. It's all too often nowadays that we have to like agree to terms and conditions. To be fair, it's usually in the form of like a pop-up and a button that we click, but we can do this in code at the command line as well. Let me go ahead and include to start cs50.h and include to start standard.io.h. Let me again, for today's purposes, do int main void, but we'll reveal next week why we keep doing that. And now for a yes/no answer, it suffices just to ask for a single char or character, not a whole string. So let's do this. Char c equals get char, and let's ask the user, quote unquote, do you agree, question mark, for instance. And now I can actually compare that value for equality with some known answers. For instance, I could say if c equals quote unquote y, then go ahead and print out, for instance, agreed period \n close quote semicolon. Else if c equals n in quotes, let's go ahead and print out, for instance, not agreed period \n semicolon. Now, there's still room for improvement here, but notice we're just now using the same building blocks in C in different ways to solve different problems. But notice on lines 8 and 12, I've used single quotes, which I alluded to earlier. Why is that the case? Why single in this case here? Yeah, it's a single character, and this is just the way you do it in C. When you want to compare a single character, you use chars and you use single quotes. When you want to use strings of text, like multiple characters, multiple words, multiple sentences or paragraphs, you use strings. So this would seem to work, but arguably I could be a little more efficient. If the user doesn't type y, I mean, frankly, I could just chop off this else if and make it an else and just assume if you don't give me a y answer, then at least I'm going to assume the worst and you don't agree. But even here, the program's not all that great. Let me go ahead and do make agree, and then do /agree, and do I agree? Sure. I'm going to go ahead and type y. Meanwhile, if I type anything else like n, or even emphatically no, that would seem to, whoops, why did that not work? Yeah. Exactly. So among the features of CS50's functions, like get char.
Moi, j'étais en train de tester un code, après je me suis rendu compte qu'il y avait des erreurs. Avec ces scrutateurs, c'était juste pour tester. Attends, j'avais juste trop d'erreurs, j'ai oublié le semicolon. Là, si je veux pas utiliser ça, c'est à moitié, je veux pas utiliser ça, je pars et je fais une ici, je mets ça. Et maintenant, on va faire une print f2. Semicolon, on dit addition. Et puis on met ça. On fait un scan f. Dans scan f, ça prend deux trucs comme il a dit. C'est quoi qu'on attend, percentage, et on stocke ça dans quoi, la variable qu'on a choisie. Alors c'est plus ou moins ça. Donc c'est là que je vais faire sur percentage t pour dire que c'est l'integer que j'attends, je stocke ça. La variable, plus ou moins ça. Non, j'ai mis ça dans mon espace. Ok, je fais ça là. Toujours l'habitude d'oublier. On va mettre ça. Percentage t. Yes. On va mettre ça. Bon, c'est ça ici. Si je fais percentage D. C'est pas ça. Bon, ça, je peux utiliser le semi-colon. Ici, c'est quoi? C'est un peu quoi? Ah oui, c'est vrai. Ils sont en train de mélanger Python. Ils sont en train de mélanger Python. Là, c'est bon. Et puis, on va faire slash edge. Ah, c'était juste là. Et là, si je mets... Ok. Ah, c'est bon. Parce que là, si j'étais en train de mettre Python, un truc, c'est-à-dire, là, je mets percentage G, mais je dois préciser c'est quoi qui doit s'afficher là. Bon, c'est plus ou moins ça. Parce que les deux ici, c'est ça qui remplace get char ou bien get int. Un peu comme on a fait ici. On fait un get int. Ça va faire les deux lignes ici. Parce que ça prête au message et puis ça dit maintenant que là, on attend que l'utilisateur entre quelque chose. Donc, scan F, l'utilisateur doit entrer un pourcentage, un int, c'est ça qui dit. Et la valeur que l'utilisateur entre, on va stocker ça avec. Moi, tout ça, c'est juste un rappel parce que j'avais déjà fait un peu l'essai, mais juste les trucs basiques.
Char is that it will enforce what type of data you're getting. So even though because I used getChar, if the user doesn't cooperate and types in multiple characters, getChar, like some of our other functions, is just designed to prompt them again, and again until they cooperate. That's useful so that you don't have to deal with that kind of error checking. But here I could type n in uppercase, and that seems to now work. But that only works because of the else. Let me go ahead and do this, which is very reasonable. I'm going to go ahead and type Y, capital Y, which you would hope works. That feels like a bug at this point. Like, it's fine if we don't want to support yes and no. We just want to support Y and N. But it's kind of obnoxious not to support the uppercase version thereof. So how can we fix this? Well, let me hide my terminal window, and I could go in and fix this as follows. I could say, well, else if C equals, quote unquote, capital Y in single quotes, and then I could do print out agreed, period, backslash n, semicolon, and then I can do else. That would work. That would work there. But what rubs you the wrong way, perhaps, about this solution, even if you've never programmed before? Just applying some of the lessons from last week. Yeah? It's redundant. I mean, I didn't technically copy and paste, but like line 14 is identical to line 10, so I might as well have copied and pasted, and that's generally bad practice. Why? Well, if I want to change the English language to say something else in that case, now I have to change it twice, and it's just, I'm repeating myself, which is just bad design. So there are ways to address this through other types of operators that we haven't yet seen. If I want to ask two questions at once, that's fine. I can do something like this. Well, if C equals, quote unquote, Y, or C equals, quote unquote, capital Y, I can tighten things up using so-called logical operators, whereby I am now taking a Boolean expression and composing it from two smaller Boolean expressions. And I care about the answer to one of those questions being true. So whether it's lowercase y or uppercase Y, this code now will work. And if it's anything else, we're going to default to not agreed. So the two vertical bars, which is probably not a character you type that often, and it varies where it is on your keyboard depending whether it's American English or something else, just means logical or. This is not relevant here, but you could also in some contexts use two ampersands to connote and, but this does not make sense. Why? Why is it clearly not correct to say and in between these two clauses? Yeah? Exactly. The variable can't both be lowercase and uppercase. That just makes no sense. So this would be a bug, but using two vertical bars here is, in fact, correct. All right, well, let's do one final flourish here besides conditionals. We had these now loops. Recall that a loop is just something that does something again and again and again. Here, for instance, to scratch how we might meow 3 times. In C, there's going to be a few different ways to do this. Here is one. You can, in C, declare a variable like I for integer or whatever you want to call it and set it equal to 3, the number you care about. You can then use a loop. And the closest to the repeat block is arguably a while loop. There is no repeat keyword in C, so we can't translate this verbatim. But we could say while I is greater than 0. Why? Because that's sort of logically what I want to do. If I start counting at 3, maybe I can just sort of decrement one at a time and get down to 0, at which point I can stop doing this thing. So I'm going to initialize a variable to I, a variable I to 3, and then I'm going to say while I is greater than 0, go ahead and do the following. And at the end of that loop, before whipping around again, I'm going to use this line of code, which we haven't seen, but you can infer I minus minus just means subtract 1 from I. So this is going to have the effect of starting at 3, going to 2, going to 1, going to 0. And as soon as it goes to 0, this Boolean expression will no longer be true. And so the loop will just implicitly stop, because that's it. So what are we going to put inside of the curly braces besides this decrementation? Well, I think I can get away with just saying meow. And that will now print 1, 2, 3 times. And yet, that's interesting. I sort of counted instinctively 1, 2, 3, even though I'm proposing that we count 3, 2, 1. So can we implement the logic in the other direction, whereby we count up from 0 instead of down from 3? Well, sure. We just have to make a few changes. We can set I equal to 0 initially. We can change our Boolean expression to check that I is less than 3 again, again, and again. And on each iteration of this loop, let's just keep incrementing I with I plus plus. And at this point, it will have the effect of doing 1, 2, 3. 3 is not less than 3, so I won't put any more fingers up. I will meow in total 3 total times. And again, if you're a visual person, here's how we might start counting at 0 initially. Check that I is less than 3, which it is initially. And if so, we print out meow. Then we increment I, and we get whisked around again to the Boolean expression, because that's how while loops work. You constantly have the condition being checked again and again. That's just how C works. As soon as I've incremented I from 0 to 1 to 2 to 3, 3 will eventually not be less than 3, so the answer will be false, so the loop will just stop. So that has the effect of achieving the same. But it turns out that looping some amount of times is so darn common that you don't strictly have to use a while loop. A for loop, so to speak, is another alternative there too, whereby the syntax is a little weird, it's a little harder to memorize, but it allows you to write slightly less code because you write more code on a single line. So the way you read a for loop is exactly the same in spirit. You initialize the variable, everything to the left of this first semicolon. You then check the condition, and the computer does all this for you. If I less than 3, if so, you execute what's inside of the curly braces. And then automatically, the thing to the right of the second semicolon happens, so I gets incremented from 0 to 1 in this case. The condition is checked. Is 1 less than 3? It is, so we print meow again, and C increments I to 2. Is 2 less than 3? Yes, so we meow again. I gets incremented to 3. Is 3 less than 3? No. So the for loop stops. So it's exactly the same, but just more magic is happening in this first line of code here, more than you yourselves have to actually write. And it's just arguably more common convention, but both of them are perfectly correct if you'd like to do that yourself. So let's go ahead and actually implement now this beginning of a cat in VS Code. Let me go back to VS Code and close agree.c. Let me reopen my terminal window and create an actual cat in cat.c. And let's go ahead and do this initially the wrong way. Include standard io.h, int main void. And then inside of main, let's go ahead and print out, quote unquote, meow, \n, semicolon. And then heck, let me just copy paste. So this is obviously the wrong way, the bad way to do this, because I'm literally copying and pasting. But it is correct. If I want the cat to meow 3 times, I can make this cat. I can do /cat. And I get my meow, meow, meow. But let's now actually use some of those new building blocks whereby we converted Scratch to C. And let me go back into this code, and I'll do the while loop first. So I could instead have done int I equals 3, if we count down initially, while I is greater than 0, then go ahead and print out, quote unquote, meow, \n, and then do I plus plus or I minus minus? I minus minus, because we're starting at 3. Now let me go back to my terminal window and clear it. Do make cat again, /cat, and we get 3 meows. And this is now arguably better implemented. What if I want to flip things around? Well, I could now change, maybe do it the normal person way. I could start counting at 0. And I can do this so long as I is less than 3. And I can do this so long as I increment I on each iteration. Now I can do make cat again, /cat, enter, and that too works. But there's another way I could do this. If I want to count like a normal person, like start counting from 1 and count up 2 and through 3, I could do this, but this is correct. It would iterate 3 times, but it's a little confusing because now I have to think about what it means to be less than 4. OK, that means equal to 3. I could be a little more explicit and say, well, do this while I is less than or equal to 3, using yet another one of those operators. So I can make a cat yet again, ./cat, and that too would work. Now, which of these is correct or best? The convention, truthfully, is, in general in code, to start counting from 0, start counting up to, but not through the value that you want. So at least you see the starting point and the ending point on the screen, if you will, at the same time. But of course, I can condense all of this a bit more and turn this whole thing into a for loop. And I instead could do for int I equals 0, I less than 3, I plus plus. And then down here, I could do print out, quote unquote, meow. And if only because I typed fewer keystrokes that time, like this feels a little nicer. It's a little tighter and more efficient to create, even though the effect is the same. Indeed, when I make this cat and do ./cat a final time, this here too gives me the 3 meows. So what could go wrong? Well, sometimes you might be inclined to do something forever. And we might have done that in Scratch. And indeed, we did when we had some things bouncing back and forth off of walls and so forth. You can achieve the same thing in code. In fact, in C, we could use a while loop. But there is no forever block. So while suffices. But recall that the while loop expects a Boolean expression. And if I want to do something forever, I essentially need an expression here that's always true. So I could do something stupid and arbitrary, like while 2 is greater than 3. Or while 1 is less than 2. I mean, make a statement of fact that never changes. Ergo, it's just going to run forever. But if the whole goal here is to do something forever and to get this Boolean expression to be true, the convention in programming is just to literally say while true. And that implies and functionally means that you will do this thing forever unless you somehow prematurely break out of those curly braces. More on that before long. So if I want to meow forever, I could now just do this. And this would be an infinite deliberate loop. But unlike a game where you might want it to keep going and going and going for some time, I'm not sure this is going to be the best thing for us. Let's go ahead and try this. So let me go ahead here and include for good measure CS50's library, if only because it too is giving us features like bools. Here I'm going to go ahead and say while true. And then inside of my curly braces, I'm just going to print out meow. Let's go ahead, \n, semicolon. Let's go ahead here and make cat one final time. Let me go ahead here and do ./cat. And this is like the annoying cat game, just like meowing, meowing, meowing endlessly. Like I've now kind of lost control over my terminal window. And mark my words, at some point you might do this too. But let's go ahead and take a juicy 10-minute break here. We have some delicious blueberry muffins out in the transept. Come back in 10, and we'll figure out how to stop this here cat. All right, so it's been about 10 minutes, and like VS Code is freaking out with high code space, CPU utilization detected. Consider stopping some processes for the best experience. So this is what happens when you have, intentionally or otherwise, an infinite loop, insofar as I've been printing out meow endlessly. And I was warned by my colleague that I probably shouldn't let this run too long because we might lose control over the environment altogether. But the answer to how to solve this is going to be Control-C. So there's a few cryptic keystrokes that you can use to generally interrupt things, as in this way. And in fact, if I go back, and you'll see, yeah, I kind of lost control over my code space here. I'm going to go ahead and try to reload the window altogether. But had I hit Control-C in time, let's hope this doesn't now go off the rails. Control-C would have been our friend. There we go. And we're back. OK, so now that we've got control over our so-called code space again, how can we go about making our meowing program a little more dynamic? Insofar as let's start asking the user how many times they want the cat to meow, certainly rather than do it an infinite number of times, and even rather than do it 3 times alone. I think we have all of these building blocks thus far. So let me go ahead and stay in cat.c here and go ahead and delete the body of the contents of my main function. And let's go ahead and do this. Let's give myself an int, and I'll go ahead and call it n for number, though I could be more verbose than that if I wanted. I'm going to set it equal to the so-called return value of getInt, which recall is going to get an integer from the user. And quote unquote, let's ask the user, what's n? Just like I asked earlier, what's x and what's y, where n is the number of times I want the cat to meow. Now, how can I use this variable? Well, we have that building block too. I could use a while loop or a for loop. And if I use a for loop, I could do this. I could initialize a variable I for integer, set it equal to 0 initially. I could then do I less than, not 3 this time, but n, so I can use that variable as a placeholder inside of the loop to indicate that I want to do this n times instead of 3. And on each iteration through this loop, I can do I++. Of course, I could be counting down if I prefer by using decrementation, but logically, I would say this is canonical. Start at 0 and go up 2, but not through the value that you actually care about. And I'll go ahead now and print out, quote unquote, meow with a \n, semicolon, back down to my terminal, make this cat again, /cat, enter. I'm prompted this time for n. I can still give it 3, and I'm going to get 3 meows this time. However, if I run it again with /cat and a different input like 4, of course, I'm going to get 4 meows instead. Now, what is getin doing for me? Well, it does a few things similar to getchar doing a few things for me. For instance, suppose that instead of answering this question correctly with a number, n, I say something random like dog. That is not an integer, and so the getInt function is designed to reject the user's input implicitly and just reprompt again, again, and again. I can try bird, and it's going to do this again. So somewhere in the implementation of get.
Ça veut dire, ok, je sais ce qu'il veut dire, mais je pense que je connais déjà. Ça veut dire, why, un peu comme ce que j'avais fait ici, each, ça serait ça. Ici, je demande directement que j'affiche. Mais maintenant, que de stocker ça, on va dire while age is not a number. It's not a number, c'est-à-dire, tant que c'est pas un number, tu dois toujours demander à l'utilisateur d'entrer dans. C'est ça, je peux dire.
There's a loop that we wrote that does this kind of error checking for you. But it doesn't do everything, because an integer is a fairly broad category of numbers. It's like -infinity through +infinity, and that's a lot of possibilities. But suppose I don't want some of those possibilities. Suppose that it makes no sense to ask the cat to meow like -1 time, and yet the program accepts that. It doesn't do anything or anything wrong, but I feel like a better designed program would say, no, like -1 makes no sense. Let's meow 0 or 1 or 2 or more times instead. So how can I begin to add some of my own error checking and coerce the user to give me the type of input I want? Well, let me clear my terminal window and go back up into my code. And why don't I do something like this? After getting n, let's just check if n is less than 0, because if so, I want to prompt the user again. And I can prompt the user again by doing n equals getInt, quote unquote, what's n, question mark, semicolon. Now, what's going on here? Well, on line 6, I'm doing two things. I'm getting an integer from the user, and I'm not only storing it in the variable n, I'm also technically creating the variable n. So I didn't call this out earlier, but on line 6, when you specify the type of a variable and the name of the variable, you are creating the variable somewhere in the computer's memory. And that's necessary in C to specify the type. If the variable already exists, though, and you just want to reuse it and change it later on, it suffices, as in line 9, just to reference it by name. It would be sort of stupid to specify the type again, because C already knows what type it is, because you told C what it is on line 6. So that's why lines 6 and 9 are a little bit different. So let's see how this now works. Let me go back to my terminal window and remake this cat. Let me do /cat again. Let me not cooperate and type in like -1 again. And notice I am reprompted this time. Fine, fine, fine. Let's type in 3. And now it works. But you can perhaps logically see where this is going. Let me go ahead and run this again, /cat, type in -1, type in -1, and it didn't prompt me again. But that's consistent with the code. If I hide my terminal window here, you'll notice that I've got 1, maybe 2 tries to get this question right. And after that, there's no more prompting of me. Now, you can kind of imagine that this is probably not the best way to do this if I were to go inside of line 9 and then move the cursor down and say, OK, well, if n still is less than 0, well, let's just do getInt again and ask what's n question mark. And heck, OK, if it's still less than 0, well, let's just keep asking the same. Right? Why is this bad? I'm repeating myself. I'm essentially copying and pasting, even though I'm retyping. I mean, this just never ends, right? Like, how many chances are you going to give the user? In spirit, you'd hope that they don't not cooperate this many times. But really, to do this the right way, we should probably prompt them potentially as many times as it takes to get the correct input. So this is not the right path for us to be going down. But of course, we have already now this notion of like a loop, whereby we could just do this in a loop, ask the question once, and maybe just repeat the question again, but the same question. So how might I do this? Well, let me go ahead and delete all of this, and let me just try to spell this out logically. So I want to get a variable n from the user, and let's go ahead as follows. While true, I know how to do infinite loops now, and even though that created a problem for me with the cat, I bet we can sort of terminate the loop prematurely like I proposed earlier as follows. I could do this, int n equals get int, and ask the user again, what's n question mark? And then I could do something like this. If n is less than 0, well then you know what? Go ahead and just continue on with the same loop. Else, if it is not the case that n is less than 0, what do I want to do? I want to break out of this loop. So this is new syntax. This is something you can do in C, whereby if n is less than 0, fine. Continue means go back to the start of the loop and do the same exact thing again. Otherwise, if you instead say break, it means break out of the loop and go to below whatever curly brace is associated with that loop. So continue essentially brings you to the top, break brings you to the bottom, if you will. So logically, I think this is right, but this code, curiously, isn't quite going to work and get me a value for n. Let me go ahead and open my terminal window again. Let's make this cat, and, cat.c, line 19, character 25 is an error. Use of undeclared identifier n. Well, what does that mean? Again, cat.c line 19. Let me hide my terminal window, highlight line 19. N is being used in line 19, but I created it in line 8. And so what's the problem? Why is it not declared, seemingly? Yeah. Yeah, this is a subtlety, but I'm creating n inside of this loop. I mean, literally between the curly braces on line 7 and 17. The implication of which, because of how C works, is that that variable only exists inside of that for loop. This is a problem of what's known as scope. The variable n only exists inside of the scope of the while loop in which it was declared. So how do I actually fix this? Well, I need to logically somehow declare that variable n outside of the loop so that it exists later on in the program as well. And there's a few different ways I can fix this, but the best way is probably to move the declaration of n, so to speak, the creation of n outside of the curly braces, and maybe kind of squeeze it in here below line 5. So still inside of main, whatever that is, more on that next week, but in the same curly braces as everything else. So I can, in fact, do this, and this is where the syntax gets a little bit different. I can solve this quite simply as follows. I can go down to a new line 6 and just say int n semicolon, and that's it. This declares a variable called n. It creates a variable called n. And initially, it doesn't give it any value. So who knows what's in there? More on that another time. But now on line 9, I don't need to recreate it. I just need to assign it a value. And because now n has been declared on line 6, and between the curly braces on line 5 and all the way down on 24, now n is in scope, so to speak, for the entirety of this code that I've written. So let me reopen my terminal window and clear that old error. Let me do make cat again. Now the error messages is gone. Let me go ahead and do /cat. What's n? Now I'm back in business, and I can do 3 for meow, meow, meow. But better yet, because I'm inside of a loop now, watch that I can do -1, -1, -1, -1, -2, -3, -50. Finally, I can cooperate with something like 3. And because I'm in a loop that by design may very well go infinitely many times until the user actually cooperates and lets me break out of that exact loop. Now, I, strictly speaking, don't need both continue and break. I wanted to demonstrate that both exist, but this is like twice as much code than I actually need. If logically, I just want to break out of this loop if and only if n is greater than or equal to 0, because I'm sort of comfortable with the idea of 0 meows, but negative makes no sense, well, I can just flip the logic. I can say if n is greater than or equal to 0, then go ahead and break. And I've tightened up the code further. I could technically do something else. I could say something like if n is less than 0, but wait a minute, I want to negate that. You can start to do tricks like this, an exclamation point with some additional parentheses so you can invert the logic. It's arguably a little hard to read, even though that would be logically correct. So I'm just going to say more explicitly as before, if n is greater than or equal to 0, break out of this here loop. All right. So this is one way to use an infinite loop, but it turns out there's another construct that you can do altogether that is in a feature of C. Instead of using a while loop and forcing it to be infinite by using while true and then eventually manually breaking out of it, there exists another type of loop altogether, and that's called a do-while loop. And you can literally say the word do, which means do the following. Then you can do exactly what we did before, n equals get int, quote unquote, what's n question mark. So exactly like before, but then after those curly braces, you use a while keyword, so at the end of the loop instead of the beginning, and that's where you put your Boolean expression. I want to do all of that while n is less than 0. So you can kind of invert the logic and now kind of tighten things up further by just telling the computer, do the following. What's the following? Everything in between those curly braces, while n is less than 0. And this implicitly handles all of the continuation and all of the breaking by just doing what you've said. Do this while this is true. But the difference between this do-while loop and a normal while loop is literally that the condition is checked at the bottom instead of the top. So when you say while parentheses something, that question is asked first, and then you proceed maybe. This condition is only asked at the very end. And why is this useful? Well, oftentimes when writing programs where you want to do something at least once, like you obviously want to ask the user this question at least once, there's no point in asking a question like while true or while anything else. You should just do it. And then you should do it again if the expression evaluates to true and tells you to do something. Now, you haven't played with these loops yet, most likely, unless you have programmed before. There's a fun sort of meme that's apropos of this moment. So let's see if this maybe causes a few chuckles. If you remember Looney Tunes here. This is funny for people in the know. There we go. Thank you. OK, if this doesn't make sense, it eventually will. And it still might not be funny, but it will at least make sense. And it illustrates the difference between do-while loop, like the Roadrunner is stopping because he's checking the condition. While not on edge, he'll run. But if he is on the edge, he's not going to proceed further. But of course, the coyote here, he's going to do running no matter what. And then only too late does he check. Haha, he's still on the edge. All right. So, thank you. All right. Now you're cool. All right. So many more memes will now make sense as a result. But let's go ahead and revisit this code and maybe do something a little bit different here, whereby we no longer want to just futz around with some of these conditionals and these loops. Let's actually make the software a little better designed. And to do this, we'll revisit an idea that we touched on last week and had to do with problem set 0, which was like create your own function. Like C does not come with everything you might want. CS50 library is not going to come with everything you might want. And at the end of the day, a lot of programming is about abstracting away your ideas so you solve a problem once and then reuse it, reuse it, reuse it. And heck, you can package it up in a so-called library like we have and let other people use it as well. So here, for instance, in Scratch is how we could have implemented the notion of meowing as by getting the cat to play the sound meow until done. We abstracted it away, and then we had a magical new puzzle piece called meow. In C, this is going to be a little weird today, but next week these details will start to make more sense. You would instead do the following. Literally type void, the name of the function you want to create, and then void again in parentheses. For now, know that this is the return value of the function. So void means it returns nothing. This is the input to, or the arguments to the function. Void means it takes no inputs. And that makes sense because literally meow doesn't return anything. It doesn't take anything. It just meows. It has a so-called side effect, audibly last week. So this means, hey C, invent a function called meow that takes no input, produces no output, but does have a side effect of printing meow.
Ouais, moi je me disais. Attends. Ok.
meow on the screen. Meanwhile, if I wanted to do something like this in code last week, where I meowed 3 times, well, that's fine. We have the building blocks for this. And here's where inventing your own function starts to get more compelling. I can abstract away the notion of meowing now. Like, this doesn't come with C. It doesn't come with the CS50 library. I just created, in the previous code, this meow function. So I can encode with a for loop and that new function, meow 3 times. But I can abstract this away further. Recall that the refinement in Scratch last time was this. I could edit the new function, and I can say it actually does take an input, otherwise known as an argument, called n. And I clarified that this means to meow some number of times. And then inside of those Scratch blocks, I repeated n times the meowing act. Well, in C, I can achieve the exact same thing, even though it's going to look a little more cryptic, but meow still returns nothing. It has an audible or visual side effect, but it doesn't return a value. But this version does take an input. And this might look a little weird, but just like before, when you create a variable in C, you specify the type and the name. When you invent your own function in C, and it takes 1 or more inputs, aka arguments, you specify the type and the name of those as well. No semicolons up there, just inside of the parentheses. And you'll get used to, with practice, this convention. But the rest of this code is exactly the same, except instead of 3, I'm now using n. So again, I'm just composing the exact same ideas as last week, even though it looks way more cryptic this week, but it will come more and more familiar with more and more practice. So how can I go about implementing this myself? Well, let me propose that we do something like this. Let me go back to VS Code here, and let me go ahead and let's really delete most of the code that I've written inside of main. And let me just suppose for the moment that meowing exists. And I'm going to go ahead and say, for the first version, for int I equals 0, I less than 3. So we're not going to take input yet, I++. And then I'm going to go ahead here and say, meow is what I want this function to do. Now, if I scroll back up, you'll see there's no definition of meow yet. So I'm going to invent that too. I'm going to go up here and say void, meow, void. And again, this first version means no input, no output, just a side effect. And that side effect, super simply, is going to be to say just quote unquote meow with a \n. And now, if I go and open my terminal window, clear it from before, do make cat, so far so good, /cat, we're back in business. But I've abstracted the function away. Now, much like last week, where I sort of dramatically dragged the meow definition way down to the bottom of the screen just to make the point that you don't need to see it anymore, out of sight, out of mind, let me sort of try to do the same here. Let me highlight and delete that, and like go way, way, way down arbitrarily, just to be dramatic, and paste it near like the 100th line of code and scroll back up. Now, out of sight, out of mind. I've already implemented the idea of meowing. We don't need to see or talk about it again. But there is a caveat in C. When I now clear my terminal and make this cat, now I've introduced a problem. And there's like more problems, it seems, than code. Let me scroll back up to the first such error, and you'll see this. On line 9 of cat.c, character 9, there's an error. Call to undeclared function meow and then something fairly arcane. But that means that meow is no longer recognized as an actual function. I know that it doesn't come from cs50.h, and I know it doesn't come from standard.io.h. It's just down there. But why is the compiler being kind of dumb here? Yeah. Yeah, because insofar as the first version worked, like logically it would seem that putting it at the bottom was just a bad idea, because C compilers are fairly simplistic. Like they won't proactively do you the favor of like checking all the way down at the bottom of the file. They're going to take you literally. So if meow doesn't exist as of line 9, that's on you. Like that is an error. So I could fix this by just undoing what I did and move it way back up to the top. But let me argue that in general, when writing C programs, the main function, which I keep using and we'll talk more about next week, is literally meant to be the main part of your code. And so it kind of stands to reason that it should be at the top, because when you open the file, it'd be nice to see the main program that you care about, the main function. So there's an argument to be made that it's a little annoying to have to put my functions all at the top, which is just going to push main further and further down. So there is a solution, and this is, dare say, the only time copying and pasting is appropriate. Let me delete most of these blank lines, which is unnecessarily dramatic, and just move it below main, as over here. The way I can, the solution here, though, is to do this, to copy the first line of the main function, its so-called signature, and then just put that one line and only that one line with a semicolon above main. And this is what's known as a prototype. So a prototype is just a bit of a hint to the compiler, a promise, if you will, that, hey, compiler, there will exist a function called meow. It takes no input, and it returns no output, semicolon. And it's on the honor system that it will eventually exist later in the file. We'll talk more about this next week, why that works, but this is sort of a promise to the compiler that it will eventually be defined. Now, what I've done here on line 4 as an aside is what's generally known as a comment. I just wanted to put on the screen exactly what I was verbalizing. Anything in C that starts with / is a note to self, like a sticky note in Scratch, which is just for the human, not for the computer. And it's a way of reminding yourself or someone else what's going on that line or those lines of code. But I'll go ahead and delete it for now as unnecessary, because now if I go back into my terminal and clear those errors, make this cat again, now it does work because the the meow function has been defined exactly where it should be. And now I can make the new version of this cat even better. I could change the function meow to take a variable n as input for the number of times. And then in here, I could do something like my for loop, for int I equals 0, I less than n, I plus plus. And then in this for loop, I can print out quote unquote meow. And then I'm going to have to change this too, because I have to copy and repaste it, if you will, or just manually fix that. But now I can get rid of all of this and do meow 3, for instance. And this now will be the second version of the Scratch code, if you will. Make cat, still going to work exactly the same, meow, meow, meow. But now I've implemented my own function that does take input, even though it doesn't happen to return any output. All right, questions on any of these examples just yet? Confusion? All right, let me add one other feature to this to demonstrate that we can take not only input, but actually produce output if we want. If I go back into this code here, let me propose that it's a little silly to be hard coding, that is fixating 3. It'd be nice to get input from the user. So I could do this. I could use int n equals get int and say something like, what's n question mark, and then I could pass n in, if only to demonstrate a couple of things. So one, now the program's dynamic. I'm going to ask the user how many times to meow, and I'm going to pass in that value n. Now this deliberately is confusing at the moment because, wait a minute, I got n defined here, used here, but then redefined here, and then reused here. So it turns out that even if you create n up here and use the name n, no other functions can see it for that same issue of scope. So for instance, suppose I didn't quite remember this, and I sort of naively just said void. Meow doesn't need to take any inputs because, heck, n is already defined in main. Let me go ahead and open my terminal and clear it, make cat, and see what error comes out here. Well, error cat. Oh, sorry. I made 2 mistakes here. I also have to change the prototype up here to say void, which means, again, meow takes no inputs. Let me go ahead now and rerun make cat. And there we have an undeclared identifier again, n. So in cat.c line 14, which is here, it doesn't like that I'm using n. But wait a minute, I created n here. But for the same logic as earlier, that's fine. You created n on line 8, but where does n exist? In what scope? Yeah, only between the curly braces, which is lines 7 and 10. So by the time you get down to 14, it's out of scope, so to speak. So it just doesn't work. So the solution is exactly what I did the first time. I can pass it into meow as input, and I have to tell C to expect that input. And I can use the same name, but arguably that's going to get confusing sometimes. But let me do this. Let me go back into my code. Let me undo this change such that now meow does take an input. But instead of just calling it n and using n everywhere for number, this is crazy, let's just call this like times. So meow takes some number of times, and then it uses that value. And now I'm passing in on line 9 n. But in the context of the meow function on lines 12 onward, that same variable n is now referred to as times, because you're passing it in as input and giving it its own name. And that's totally your prerogative. It's just a matter of scope. I mean, I could have called it M or some other letter of the alphabet, but times is even more clear, because that's the number of times I want the cat to meow. But again, the whole point here is just this matter of scope. All right, so let's take a higher level look now at some of the things we've been thinking about, and then we'll do a final deep dive or two on some of the some of the problems that we can solve with all of these building blocks, and some of the problems that we're sort of ignoring for now. So when it comes to writing good code, CS50 and really the world in general tends to focus on these kinds of axes: correctness, design, and style. What does this mean? Correctness just means, does the code work the way it's supposed to? In the context of a class, it should do exactly what the homework assignment, aka problem set, tells you to do. In the real world, it should do exactly what someone decided the software should do: the product manager, the CEO, or the like. Correctness just means it behaves as it should. That's different, though, from how well designed the code might be. And we've seen that a few times. I've had some simplistic examples in Scratch and C that were 100% correct. Like, it did the right thing logically, but I was wasting the computer's time, I was wasting the human's time by asking more Boolean expressions than I needed to, and so forth. So design is more about, like in the world of English, like not only saying things that are correct, but doing it well, like in making a good cogent argument, not just one that happens to be correct. Style, meanwhile, is the third axis on which we might evaluate the quality of someone's code, and that's more of the aesthetics. Like, is everything pretty printed? That is, nicely indented? Are variables well named and not just called XYZ arbitrarily or something like that? So style matters really to other humans, not to the computer.
Je vais juste prendre noter ça, comme ça, dans ce que je suis en train de faire. Le problème de...
but to other humans. And to illustrate these, you'll see that in problem set 1 onward, you'll be given a number of tools that you can use. So one of those tools is called Check50. And in each problem set, problem in C and Python and other languages, you'll be showed how you can test your own code. And you can literally run a command that CS50 created called Check50. You'll then specify what's called a slug, which just means a unique identifier for that homework problem. And you'll get quick feedback on whether or not your code is correct. It doesn't mean it's well implemented or well designed or pretty, that is well stylized, but at least that's the first gauntlet in getting good code submitted. Design, though, is much more subjective. Design is something you get feedback on from a human, for instance, in section or a teaching assistant, or in software. You can actually see atop VS Code, there's a couple of buttons that I haven't yet used but could. Design 50 is built on top of the CS50 duck, whereby if you have a program open in a tab, you click Design 50, you will get ChatGPT-like advice on how you can improve, not the correctness of that code, but the design of that code, the quality thereof, which is a bit more subjective and modeled after what a good teaching assistant might say. Style 50, meanwhile, is a third tool that will provide you with feedback on the style of your code. And it will show you on the left what your code looks like, and on the right what your code really should look like, insofar as it should be consistent with what we've taught in class and consistent with CS50's so-called style guide. And those of you who have some prior programming experience undoubtedly won't like some of CS50's stylistic choices, and that's going to be the case in the real world too. But as I alluded to earlier, in typical companies, you would have an official style guide or tool to which everyone adheres, so that everyone's code actually looks the same as everyone else's, even though people have contributed different solutions to problems. So correctness, design, style is not only how we, but really the world writ large tends to evaluate the quality of code, and we do it by way of these CS50 specific tools here. All right, how about one final flourish then to this here program? Back in VS Code, I've got a correct solution right now. It's well styled, I'll stipulate, even though it could stand to have some more comments. So for instance, I could do something like this, like meow some number of times, a comment to myself. Or up here, I could say something like get a number from user, just to remind myself and my TA or my colleague what it is this code is doing. But what more could I do in the way of design? Well, this function here, getInt, will indeed get me an integer, but not just positive or 0, but negative. And I could go in and add a bunch of code like before, like I could actually do, instead of this line, I could do something like int n semicolon do the following, or n equals getInt, and then I can say what's n question mark, and then after that I can do something like while n is less than 0, keep doing that. So I can have a pretty verbose implementation of getting user input, or I can implement another function of my own that only gets a positive integer or non-negative integer from the user. For instance, I might do something like this. I could declare at the maybe below my main function, a function like this. Int, how about get n, and then inside of this I might say void because I'm not going to pass in any inputs. Then inside of this function is where I'm going to do int n, do while n equals get int, quote unquote, what's n question mark. And then down here I'm going to do while n is less than 0. But rather than do something immediately with n, because I'm no longer inside of my so-called main function, what I'm going to do, which is new, is return this value n. And notice that this notion of returning a value, which is the first time I've done this explicitly, is consistent with this little hint here on line 19, which implies that this get n function, which I'm inventing, is going to return not void, which means nothing, but an integer. And that's the whole purpose of this function in life now. If I scroll back down here, I can get rid of this whole block of code and just say get n from the user, and then I can immediately call meow with that value. I need to do one other thing. I need to highlight this line of code here, and I'm going to go ahead and add another prototype up top, which is the only time, again, for now, that copy-paste is encouraged and best to do. So I've invented my own function, get n, the whole point being now I have this sort of abstraction here of a function whose whole sole purpose in life is to get me not just an integer, but one that is 0 or positive and not negative. If I open my terminal window, clear the mess from before, make this cat, /cat, what's n3, I'm now back in business. And again, we've essentially translated from scratch last time into C this time exactly how we might modularize now the code, abstract away these lower level details, and ultimately create my own function that, as before, takes not only arguments, but in this case has not only side effects, or doesn't have side effects, but rather a return value this time. All right, so as you walked in, we had a little walkthrough of Super Mario Brothers playing from yesteryear, which was a side-scrolling game in which Mario would jump down and go up, down, left, right, and try to collect coins and make it to the end of the level. There's a lot of obstacles throughout this kind of game, whereby the world might look a little something like this. Like there's a pit that Mario's got to jump over, and then there's these coins hidden typically behind these question marks that he can jump up and hit his head with and actually accrue points. Now, we're not going to do anything graphical just yet. We're leaving graphics behind for now in the form of Scratch. But with C, we can implement some of these ideas. For instance, if I were to write code to generate just this row of 4 question marks, I dare say there's a bunch of ways we can do this. In other words, let's see if we can't use all of today's building blocks to start implementing our own tiny version of Super Mario Brothers in a file, say, called mario.c. So let me open and clear my terminal window. Let me run code mario.c. And let's just try to do something super simple like print 4 question marks in a row. Well, to do this, I need printf, so I'm going to include standard.io.h. I'm then going to do int main void. More on that next time. And inside of main, my default function that just automatically, as before, gets called for me, I'm going to print out the simplest possible implementation, just print out 4 question marks like that. So no need per se for a loop just yet, but I think we can go down that rabbit hole too. Let me go down into my terminal window, make this version of Mario, /Mario, enter, and voila. We have a very black and white version, textual version of 4 question marks in the sky. Now, I'm kind of cheating here by just hard coding 4 question marks. What if I wanted not 4, but 3 or 5 or some other number? Well, we could do that with a loop too. So let me change this code here and do something like this. For int I equals, say, 0, I less than, say, 4 for now, I++. Then inside of this loop, I can print out 1 question mark at a time, semicolon. Now let me go back to the bottom, make this version of Mario, /Mario, enter, and voila, it's not actually correct this time. So why am I getting a column instead of a row with this here change? Yeah.
Because every time tu print et tu passes une next line.
Yeah, so I foolishly included the \n after each question mark. OK, so that seems like an easy fix. Let me get rid of that. Let me now recompile Mario, rerun Mario, and now, so close. Now I've just done something stupid. All right, I need the \n, so I think I do want this here. Or what do you propose instead? Yeah, I should really put the \n outside of the loop, so once I'm done printing all of the question marks, then I get the \n. And that's fine. Even though we haven't seen this before, \n is an escape sequence that you can certainly print by itself. So I do quote unquote \n outside of the loop, below those curly braces. Now if I do make Mario, /Mario, now I get the 4 question marks in a row, as well as the new line at the very end. So again, kind of a little baby exercise, but demonstrative of how you can just take a few different techniques, a few different building blocks we've used to compose a correct solution to what a moment ago was a brand new problem. Well, let's try another. So later on in Super Mario Brothers, when you go into sort of the underground world, you see, or rather, it's still above ground, you see a column of bricks like this that he has to jump over. So those here. How might we make a column? Well, we kind of had that solution already. And in fact, if I go back to VS Code here and just change this version of Mario, I think we can design this thing to be pretty simply the same. I is less than 3, though. And I do want to put the \n at the end there. Make Mario, /Mario, and albeit textual, I've got my column of 3. Let's see, I don't want question marks. Let's make this a little better. Maybe we'll use the hash symbol, because that kind of sort of looks like a square. So make Mario, /Mario. OK, now we're back in business. But let's make it more interesting by going into Mario's underground now. And here's the third and final Mario problem, whereby we want to implement like this 3x3 grid of bricks circled here. So this one's interesting because we've never done something in 2 dimensions. I did horizontal, I did vertical, but we haven't really composed those ideas into the same. So let me now think a little harder this time about how I can print out row, row, row. And this is where, if you have in your mind's eye any familiarity with like old school typewriters, it's kind of the same idea where you want to print a row of bricks, then go back to the beginning, a row of bricks, then go back to the beginning, and a row of bricks. And that's kind of what printf has always been doing for us. It's printing line by line by line of text. It's not jumping around. So we can leverage that perhaps as follows. Let me go into my main function here. And if I want to print out something 2-dimensional, let me kind of think about it as rows and columns. So maybe I could do this for int I equals 0, I less than 3, I plus plus. Why? Well, I want to do something 3 times. Even if I have no idea where I'm going with this solution, I at least want to do something 3 times, like 3 rows of text. But how about this? On each row, what do I want to do? I want to print out 3 things. So I could steal this idea, like int I equals 0, I less than 3, I plus plus. And then inside of this loop, let me just print out 1 brick at a time. No new lines yet, 1 brick at a time. But there is a bit of a problem here. This is correct to nest loops in this way. Totally fine to have an outer loop, totally fine to have an inner loop. But I probably don't want the inner loops variable competing with the outer loops variable by giving them the same name. And that's fine. It is pretty conventional in code. When you want another integer, and it's not I, because you've used it already, fine. You can use j. So using I and j and k is generally fine. If you're using L, M, N, O, at that point, you're probably doing something wrong. There's no hard line, but at some point, it gets ridiculous, and you should be coming up with better variable names. But I and j, maybe k is fine. So now, what's really happening? Let me propose that this is my for each row. This is my for each column. I want to print 1 brick. Now, this isn't quite correct, but let me go ahead and make this version of Mario, /Mario, and now there's what, 1, 2, 3, there's 9 bricks there. So I'm close, right? It's supposed to be 3 by 3, 9 total. What do I want to do, though, to get this just right? Yeah, over on the left. Yeah, on what line number would you, or after, where would I put the new line? Because I think I don't want to put it here, because I'm going to get myself into trouble as before. How about in back? After the what? After 13, yeah. So after I finish printing each brick in the column from left to right, I'm going to go ahead and print out, I think, a single new line here, nothing else. And now if I open my terminal, run make Mario again, /Mario, now we've got it. And it's not a perfect square, because like this one is, because like the hashtags are kind of more vertical than they are horizontal, but it's pretty darn close. The takeaway here being, you can certainly nest these kinds of ideas and compose them. And honestly, I and j is maybe making this more confusing than necessary. I could just give these better names, like row, 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 and then maybe call for column or column. I can spell it out if that's clearer. Column, column, just to make clearer to myself, to my TA, to my colleagues, what exactly these variables represent. And indeed, like an old school typewriter, the outer loop is handling row by row by row. But each time you're on a row, you first want to do column, 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 and that's what logically the nesting is achieving. And again, if I do make Mario, /Mario, all I've done is change variable names. It has no functional effect beyond that. Now, this is a little more subtle, but there is a bit of duplication in this program. There's a bit of magic. And this is subtle, but does anyone want to conjecture what still could be improved here? What is maybe rubbing you the wrong way? Yeah, I've hard-coded the 3 here and here. It's not a big deal. It's like an in-class exercise. Like, who really cares if I'm just manually typing 3? But if I want to make this square bigger and bigger and bigger over time, I'm going to have to change it in 2 different places. And I've conjectured last time and today, eventually that's going to come back and bite you. You're going to do something stupid, or a colleague isn't going to realize you hard-coded 3 in multiple places. Like, just bad design. So how could we fix this? Well, we could just declare a variable like n, set it equal to 3, and then use n in both places. And that's pretty darn good. That's better, because now we are reusing the value. But we can do one better than this. It turns out in C, and in many languages too, there's the notion of a constant, whereby if you want to store something in a variable, but you want to signal to the compiler that this value should never change, and better still, you want to prevent yourself, a human, or not to mention a colleague, from accidentally changing this value, you can declare it to be constant, or const for short. So if I go back into VS Code on line 5 now and say const int, that means that n is an integer that has a constant value. So if I do something stupid later in my code and I try to set n equal to something else, the compiler won't let me do that. It will protect me from myself. So it's just a slightly better design as well. All right. Questions on any of these here Mario examples? The first of our sort of real-world problems, albeit simplified textually. All right. Let's focus lastly on things we can't really do well with computers, namely some of the limitations thereof. So here is a cheat sheet of some of the operators we've seen thus far. We played with these with comparison and doing some addition or the like. But here we have addition, subtraction, multiplication, division, and the modulo operator, which is essentially the remainder operator, which you can do with a single command, with a single operator like this. Let's use some of these to make our own calculator and see what this calculator can and can't do for us. So back here in VS Code, let me open my terminal. Let's go ahead and create a program called calculator.c. And in this program, let's do something super simple initially that just like adds 2 numbers together. So let's include first CS50.h so we can use our get functions. Then let's go ahead and include standard.io.h so we can use printf. Let's just copy paste our usual int main void. And inside of main, let's do this. Declare a variable x, set it equal to getInt, and let's ask the user what's x question mark. Then let's declare another variable y, set it equal to getInt, and ask the user what's y question mark. Then let's do something super simple, like give me a third variable, heck, we'll call it z, set it equal to x plus y. And then lastly, let's just print out the sum of x plus y. So this is a super simple calculator for addition of 2 numbers. Printf, quote unquote, what's the answer going to be? Well, it's not %s. This was quick earlier. What's the placeholder to use for an integer? %i \n. And what do I want to substitute for that placeholder? Just z in this case. So we haven't quite done this before, but again, it's just the composition of some of our earlier ideas. I can go ahead and make this calculator, enter, /calculator, enter. What's x is 1, what's y is 2, and indeed, I get 3. So not a bad calculator. It seems to be working correctly, but it's maybe not the best design. Like, it's generally frowned upon to create a variable like z if you're only going to use it a moment later in one place. Like, why are you wasting my time creating a variable just to use it once and only once? Sometimes it's fine if it makes your code more readable or clearer. And in fact, it might if I called it sum. Like, that's arguably a net positive because I'm making clear to the reader that it's the sum of 2 variables. But even then, I'm quibbling. I could just get rid of that third variable altogether. And heck, I could just do x plus y right here. That's totally fine and reasonable, especially since it's still a pretty short line of code. It's not hard for anyone to read. Feels like a reasonable call. But this hints at, again, my comment on design being subjective. There's no steadfast rules here. Some of the TAs might disagree with me, but like, this feels fine. It's readable, which is probably the most important thing ultimately. Let's make this calculator, /calculator, enter, 1, 2, and we still get 3. So the code now is still working. As an aside, if you're starting to wonder how I type so fast, sometimes I'm kind of cheating with autocomplete. So if I know I want to create a program called calculator and calculator.c exists, I can start typing cal tab, and you can hit tab to sort of autocomplete the rest of the file name if it happens to exist there. Better still, if I want to go back to previous commands I've typed, I can actually use my up and down arrows to go through my history. So if I go up, 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 you'll see all of the recent commands I typed, and that saves me time too. So just little keyboard shortcuts that speed things along. All right, well, let's do something like this. Not just addition. Why don't we use some multiplication? So how about we prompt the user not for two numbers, but how about just one, initially x, and let's go ahead and multiply x by 2. And I would do x asterisk 2, which is the multiplication operator in C. Let's make this version of the calculator, /calculator. And now what's x? Let's do 1. So 1 times 2 is 2. Let's do this again. Let's type in 2. 2 times 2 is 4. Let's do this again. 3. 3 times 2 is 6, and so forth. That's fine. It seems to work. But maybe let's implement like a recent meme from the past year or two. How about this? Let's see if you recognize it as we go. So I'm going to get rid of this code altogether. And inside of my calculator, I'm going to do something like int dollars equals $1 by default. Then I'm going to deliberately induce an infinite loop just for demonstration's sake. Then I'm going to do a character from the user and say something like this using getChar, which gets a single character. How about I'll tell the user, here's this many dollars, %i, with the US dollar sign before it. Double it and give to next person, question mark. You're familiar with that one. And I'm going to prompt them for a yes, no answer, but I'm going to plug in the current number of dollars so they know what they're wagering on. Then below this, I'm going to say if the character the human typed in equals y for yes, then I'm going to go ahead and do dollars times equals 2, which recall was our shorthand notation for doubling something in this case. I could more pedantically say equals dollars times 2. But again, I can save some keystrokes and do times equals 2 instead. There's no plus plus, there's no star star trick, asterisk asterisk trick. You have to do it in this way minimally. However, if the user does not want to double it and give it to the next person, then let's do an else and just break out of this infinite loop altogether. But notice what I've deliberately done. In getChar, similar to printf, I have included a placeholder. Why? We implemented getChar and getInt and getString just like printf in that you can pass in placeholders and plug in values. Why? Well, again, for the meme's sake, I want to be able to tell the user how much money I'm about to hand them when I ask them the question, do you want to double it and give it to the next person? I want to see the number. And the dollar sign is just because we're talking about dollars. The %i is because we're talking about integers. All right, if I didn't mess this up, let's make this version of a calculator or meme. So far, so good. /calculator, enter. Here's $1, which was the initial value of my dollars variable on line 6. Double it and give it to the next person. All right, y. Here's $2. Double it and give it to the next person. OK, 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 OK. I'm going to do it faster. It's getting pretty good. You can see the power of exponentiation. It's getting pretty high. Let's keep going. Keep going. Lot of dollars. Too far. That does not happen in the memes. What happened here? What's going on? Yeah, what do you think? Exactly, good intuition. Because the computer only has a finite number of bits allocated to each integer, I hypothesized earlier that it's usually 32 bits, maybe 64 bits, but it's finite, which means you can only count so high, and it's roughly 4 billion, or again, an integer by default can be negative or positive, so it's roughly 2 billion, and that's pretty close to what we were getting here. In fact, we overflowed the integer in memory. In fact, integer overflow is a term of art, whereby you can overflow an integer by trying to store too big of a value in it. And the reason for this is, again, to make this clear, this is a piece of memory inside of a laptop or a desktop or some other device. And in these little black chips is a whole bunch of bits, or really bytes, that can store information electronically. But they allocate those bits in units of 8, maybe 16, maybe 32, maybe 64, but finitely many per value. And whether we're using 32 or 64, you can only count so high if you have a finite number of bits. And we've seen this problem even on a small scale with our light bulbs last week. If we have a 3-digit number as represented by like 3 physical light bulbs or 3 tiny transistors in a computer, I can count from 0 to 1 to 2 to 3, to 4, to 5, to 6, to 7. If I want to count to 8, though, I need a 4th bit. But as the red suggests, if you don't have a 4th bit, for all intents and purposes, that number is just 0. Or as an aside, depending on how you're representing your number, sometimes a leading 1 indicates that the number itself is negative, which is why in VS Code we actually saw both symptoms. First, we went negative because we wrapped around logically, much like that 1 resulted in our getting back effectively to 0. And then we did indeed end up on 0 ultimately. So how can we chip away at this? Well, a couple of solutions perhaps. Let me close my terminal window here, and instead of using an int, well, let's just kick the can down the road. Let's use a long, which is 64 bits. So at least we can give away even more money in this scenario. I can't use %i, I need to use %li now for a long integer. But I think at this point, if I go back to VS Code's terminal window here, and I quit that program by hitting Control-C quickly, now I'm going to go ahead and do make calculator again, /calculator, and I'm just going to keep hitting y. But because I'm using a long int now, and thus 64 bits, if I do this long enough, it's going to get crazy high and much, much higher than before. High enough that I'm not going to keep clicking y, enter, because we're never going to hit the boundary. But eventually, especially if I did this in a loop automatically, it would certainly, OK, I guess exponentiation works fast. OK, so it did work. I didn't think I was going to hit it enough times. But the same problem happened again. We overflowed this long integer, even using that many bits, because I was talking so long, I kept hitting y enough times to overflow even that long integer. So that, too, was a problem. And this happens truly in the real world. So picture here is a Boeing 787 from a few years back, long before there were all the more recent problems with Boeing planes, whereby after 248 days of continuous power, which is kind of a thing in the aviation industry, like time is money, and generally they want the planes in the air as much as possible, which means they want them powered on as much as possible, which means they don't like turn them off at night. They keep them going and flying. After 248 days, the New York Times reported a few years back that a Model 787 airplane that has been powered continuously for 248 days can lose all alternating current electrical power due to the generator control unit simultaneously going into fail-safe mode. This condition is caused by a software counter internal to the GCUs that will overflow after 248 days of continuous power. Boeing is in the process, at the time, of developing a GCU software upgrade that will remedy the unsafe condition. So literally what this means is that the power to these planes would just shut off if the planes were on for more than 248 days at a time. And this was a common thing for planes to be maximal power. Why was this actually happening? Or what was the solution? Well, the short-term fix, because it took a while for Boeing to fix this, was what? What would you do if the symptom is that the plane shuts off mid-flight after 248 days? Yeah. Literally turn it off and back on again, much like you've probably been taught with your phones and computers and any other electronic devices that somehow freak out on occasion. Reboot the plane. Now, why is that? Well, anytime you reboot a phone or a laptop or a plane, all of those variables get reset to their default values, which if it's the first line of code, like in some of my examples, gets set back to 0 again. For instance, the first line of code is executed from top to bottom. So this effectively solved the problem, but when they finally rolled out a fix, then you didn't have to do that anymore. But the source of the problem is essentially that they were probably using 32-bit integers, but also negative values. So they had 31 bits at their disposal to count to positive numbers. And 248 days is roughly how many tenths of a second there are, which means once you count in tenths of a second for 248 days, you would overflow an integer, and the power would shut off effectively because something ended up going to 0. So there was a lot of sort of marketing speak or technical speak in that, but it boiled down to just a simple integer overflow. There's a historical bug in Pac-Man, if you've ever played this in any of its forms, whereby you can play up to level 255, but because there was a missing if condition that checked what level you were on, you could accidentally garble the screen if you were amazing at Pac-Man, because they too would overflow an integer and just random characters would end up appearing on the screen. So it's sort of like a badge of honor to actually hit level 256 in this way because of this bug. But there's yet other issues we can see here, and if you don't mind, we might go a couple minutes over, but let me just demonstrate what these examples can do for us here. If I were to revamp my calculator here as follows, by clearing my terminal window after hitting Control-C to kill that, let me go ahead and get rid of all of this meme code here, scrolling down to the inside of main, and let's just do a couple of things like this. Int x equals quote unquote, what's x, question mark. Then let's go ahead and do int y equals get int, quote unquote, what's y, question mark. Then let's go ahead and print out just x divided by y. So here's a %i\n, x divided by y. This would seem to be a calculator now for division, which I can make as before. And actually, sorry, I don't want to do missing terminating. Oh, sorry. Missing a double quote there was an unintended bug. So if I make this here calculator, do /calculator, type in 1, type in 3, I get 0, which is weird. What if I do instead maybe 2 and 3? It's 0 instead of 0.66. What if I do 3 and 3? Well, that curiously works. But if I do something like 4 and 3, which would be 1.33, that too doesn't seem to work. So there's this other issue in computing when you have finite numbers of bits known as truncation, whereby even when you're trying to do floating point math, like with a decimal point, if you are using an integer, you're going to throw away everything after the decimal point unless you're explicitly using the right data type. And we saw an allusion to this earlier. If I actually go in now and change my values from integers to floats and change the %i to a %f and remake this calculator, now I can do 1 divided by 3 and I actually get back their response. But there's another issue latent here, which happens too in the real world, whereby I'm going to tweak this %f to be a little arcane. It turns out you can tell C how many digits you want to show, how many significant digits you want, if you will, by just using a dot and then a number, like 50 arbitrarily. And contrary to what you might have learned in grade school, this calculator would seem to think that /calculator 1 divided by 3 is not 0.33333333 infinitely many times. There's all this random stuff happening at the end. Long story short, this is because computers, one, only use finitely many bits even to represent floating point numbers. And if there's an infinite number of those, you can't possibly represent every possible floating point value. So we're essentially seeing an approximation of 1/3 precisely, but this too happens quite a bit in the wild. There's really no solution to this other than by throwing more bits at the problem using a double instead of a float, or at least somehow trying to detect this and catch this. That then is what we'd call floating point imprecision. But to tie this together and sort of induce a bit of fear and for the coming years, these things happen all of the time. Back when I was finishing school, there was the so-called Y2K problem, or year 2000 problem, whereby for decades computers had been using not 4 digits to represent years, but just 2, because it was convenient. It was more efficient because you use half as much memory to represent maybe the year 1999 just using 2 digits instead of 4. Of course, when the year rolled around from 1999 to 2000, if you didn't have these numbers even in memory, you might confuse 2000 with 1900, which was the presumption if you're only storing 2 digits. So we screwed that up, and thankfully the world scrambled. And if you read up on Wikipedia and news articles from the time, everyone thought the world might very well end. But it didn't, so you'd think we'd have learned our lesson. Unfortunately, another such problem is coming up in the year 2038, whereby historically, since the 70s and prior, computers have generally used 32-bit integers to keep track of time, the date and the time, by means of counting how many seconds have passed since January 1st, 1970. And all of the math is just relative to that date because that's when computers were really starting to come onto the scene, if you will. Unfortunately, there's only 4 billion values you can count to, or 2 billion if you're doing negatives, from January 1st, 1970. And so, on the date, January 19th, 2038, we will overflow a 32-bit counter. And suddenly, if this problem is not fixed by you or other people before the year 2038, our computers and phones and other devices may very well think it's December 13th, 1901. So there are solutions to these problems. CS50 is all about empowering you with solutions to these problems. But if you'd like to scan this here code, this will add that date to your Google Calendar or your Outlook calendar. Keep an eye on it. That, though, is week 1 for CS50. Problem set 1 will be in your hand soon. We'll see you next time.
Ok, ça serait trop. J'étais pensé, j'étais en train de regarder un truc. Après, je me suis dit, oh, je pas vu ça au début. Là, il montre comment on peut regarder ça. C'est vrai, l'introduction, je n'avais pas vu, mais disons, regardons un peu à quoi ce côté de faire ressemble. Là, je vais traduire pour le contenu. Ça serait plus ou moins ça. Ici, Avec et sans cause, mettre l'accent sur l'exactitude, la conception aussi. Bon, moi, je préfère ça. So issues for this motion listen. Ça c'est watch lecture, recommander d'apprendre watch, d'apprendre progrès. Alors tu peux directement watch lecture, tu peux directement tomber sur progrès, mais je pense que juste pour les notions, je vais regarder ça. Et puis le projet final. Donc c'est aussi que vu que l'école commence aussi bientôt pour moi, ça serait un peu compliqué de suivre comme je suis maintenant. Pour les 2 premiers semestres, c'était facile parce que j'ai juste avec le taf. Mais avec un collègue, ça sera un peu complexe. Je pense que je vais peut-être retomber, faire ça juste les samedis, les dimanches, c'est pas trop long. On va voir. Pour l'instant, on continue avec le temps, on va voir comment on va programmer le cours, mais je sais seulement que ce week-end, je dois déposer Scratch vu qu'on a déjà fini. On doit juste regarder si on a d'autres bugs. Donc c'est ça. Et C, on va regarder le problème de C et voir pour l'instant, disons, on va suivre, regarder ça et ça, peut-être en offline. Puis regarder le problème dans il va je montrer, regarder la section et puis regarder les shots. C'est juste les petits trucs. J'avais vu comment à quoi ça ressemble. Donc c'est quand même aussi efficace. Et aussi, on va voir aussi le problème. Sur, sur quoi le problème s'agit, quoi je dois faire, des trucs comme ça. Mais pour l'instant, avant d'arriver sur ce problème, parce qu'on reste 15 jours de temps, avant d'arriver sur ce problème, on doit d'abord finaliser le problème de 8 puis 0 et déposer. Parce on a déjà fini, mais on n'a pas finalisé, c'est-à-dire j'ai pas réglé les quelques bugs. Donc c'est plus ou moins ça. Donc ça serait ça, et après, peut-être demain, si je finis ça, si je finis pas, on sera en train de voir les shots et les sections, et puis on va entamer sur le problème. Je sais pas trop, mais on va voir ça demain. Donc c'était tout pour aujourd'hui, on se dit à la prochaine pour une autre vidéo.